All right, ladies and gents, so up next is your tutorial on inverse trig functions. So yesterday you learned about trig functions, and those trig functions will allow you to find the missing sides of triangles. Today we're going to look at inverses, which allow you to find the angles. So make sure you know the difference. Regular trig is for sides. Inverse trig finds angles. Right, so you know all about SOHCAHTOA and those sides. Those relationships are still used in this lesson. But now look at number 1 here. Again, this is from your worksheet for today. But look at the missing angle. You've got a right triangle, but we've got two sides now. So from that angle, you've got an adjacent side, and you've got a hypotenuse. So using SOHCAHTOA, A and H, adjacent hypotenuse, is cosine. But we're going to use this inverse thing, and thanks to Google, there's no good notation which I've found yet. But I'll show you what this actually looks like. So the inverse cosine of x is 9 over 10. Again, adjacent over hypotenuse. So what we're going to do is switch it around to put it in your calculator. So notice how the x and the 9/10 switch place. Right, there they are. So let's put this in your calculator now. So I actually took one of the borrowed calculators from Park, and I'll put it back in. I'll show you what the inverse cosine of 9/10 looks like. So bear with me as I switch over here. So if you notice on your graph or on any calculator that has the trig function, sine, cosine, and tangent, you'll notice up above, these are the inverses. That's the notation that Google won't let me put in. So that's sine inverse, sine to the -1, cosine inverse, cosine to the -1, and tangent to -1. Right, so those are the inverses. And by the way, I'm going to post a video shortly about how to get this calculator. You can use this too online. All right, we'll do that in a minute. But we want to do the inverse cosine, so that inverse is up in blue. I do second cosine. Look, there it is. And if we put in our 9 divided by 10, we'll do the inverse cosine of 9/10. If you hit enter, that's a value that you may get. And by the way, this is actually a bad value because you're looking for an angle. So this is great that it comes up. If you get a small decimal like that, go into mode and see how it says radian in degree. You have to be in degree mode. So I can go down and go over to degree and then press enter. This will make it better for me, so I can do second quit. And I can actually put this back in again. Actually, a little shortcut, hit enter. Boom, there's your angle, 25.84 degrees. So yeah, double check your mode to make sure you're getting what looks like a degree, so 25.84. Let me just switch back over. So your 25.84 degrees is actually going to be option A. They round these up. Right, so put as choice A as your answer for this one. So now similarly on the other problem here, I'm going to put this back in and correct this. So we're going to go through and put in your inverses for this problem. All right, so in this problem for number 2, again, here's your angle. From there, that's your reference angle. The opposite side we have is 10 and the adjacent. So opposite and adjacent will tell us tangent, right, as a SOHCAHTOA. So now I need the inverse tangent, right, of x to find 10 over 11. And again, once you switch the x and that fraction, switch them around, we'll now do the inverse tangent of 10 over 11 and see what that gives us. So back to my calculator. Inverse tangent is up here. I can do second inverse tangent. And we had 10 divided by 11. Again, the nice thing is it's going to give you your angle automatically. And there it is, 42.27 degrees. All right, so the inverse will work out there. And we go back, 42.27. Right, that's going to be your angle. And as in typical fashion, it's rounded down right here, so it's going to be choice C. All right, so hopefully this works out well and explains to you the benefit of the inverse trig functions. Remember, they only find angles, but you're going to have to use that inverse trig notation because we're finding the angle here. So inverse tangent, and here inverse cosine. All right, so again, let me know if you have questions, and I will talk to you soon.